The question number 16 is a piece of wood is floating in a liquid kept in bottle. The bottle is connected to an air pump. When the air is pushed into the bottle from the pump, the piece of the wood will float with, and it says, ignoring the compressibility of the liquid. So this was a piece of wood which was floating in this one, and air was removed. So it was floating with this part of this one. Now see, the upthrust is because of the pressure difference at top and bottom. And when the air is pushed inside, what do you find? So, and as the air comes into this side, if the pressure difference remain the same, the submerged part will remain the same. So answer is the first one to this question. The question number 17 is a water column is held in a vertical glass tube as shown in the figure. If R is the radius of the tube and sigma is the surface tension of water, then the maximum mass of the water which can be held by the tube. Now see, at both the points the surface tensions are acting, and the surface tensions at top and bottom will balance the weight of this body. Now what is the surface tension of this one? If you look at the top point, so the sigma into 2 pi r will be the force acting up, and the same will be the force acting at this point, sigma into 2 pi r. So net upward force is equal to sigma 2 pi r double to this one, and that is balanced by the weight of this one, liquid. Now what should be the m? So m should be equal to 4 pi sigma r divided by g, and the last option is 4 pi r sigma by g. So answer to this question is the fourth option. Question number 18 is a hole is made at the bottom of the tank filled with water. If the total pressure at the bottom of the tank is 1.5 atmospheric, then the velocity of flux. Now we have to find the velocity of flux and see as the liquid is coming outside. So pressure, this is inside, and outside pressure is this. And we apply Bernoulli's theorem inside and outside. Let's say outside the velocity is v. So the pressure inside plus inside velocity will be 0. And this is assumed 0 level. And outside the pressure is atmospheric, and this would be the velocity of the liquid coming out, and potential energy per unit volume again 0. So now P minus P naught, the pressure difference, is equal to half of rho into V square. Now it's water coming out, and P minus P naught is, P's pressure is 1.5 atmospheric and this is 1 atmospheric, and that should be equal to 1 by 2 into rho into V square. And let's fill the value. So 0.5 atmospheric, 0.5 into 10 is power 5 is equal to 1 by 2, N2 density is 10 is power 3 into V square. Now 2 goes to this side, so V square comes to be the 100. So therefore V should be equal to root of 100 meter per second. So answer to this question is the second option. The question number 19 is the neck and the bottom of a bottle filled with water are 1 centimeter and 10 centimeter in radius respectively. If a cork is pressed with a force of 10 Newton in the neck at the bottle, then the force exerted on the bottom of the bottle is, ignore gravity, says. This is like this. The top is the bottle and this is the bottom. So this was connected like this. Now what is saying that this has the radius of 1 centimeter and the bottom has the radius of 10 centimeter. Now when you apply force on this one, on the liquid, the force is 10 Newton applied. Now by the pressure concept, by Pascal's law, the pressure same one is transferred to bottom, and pressure is 10 divided by pi r square, and this become F at the bottom, and area is equal to pi into capital R square. So pi cancel out. So 10 divided by r square, that is equal to 1 square. I take the same unit on both sides, F divided by 10 square. So therefore F become equal to 1000 Newton. So your correct option is the third one. So answer is 3. Question number 20th is choose the correct statement among the following. The surface tension depends on the area of the surface. The false statement. Surface tension rises due to intermolecular cohesive force. So that's the truth. On increasing the temperature, surface tension always increases. It depends on the nature of the liquid also. So at critical temperature, surface tension become infinite. No, it's wrong. This is 0. So the correct option is the second one, that surface tension rises due to intermolecular force of attraction. So answer is 2 to this question.